Hello and welcome to a new video on IGCSE mathematics. In this video, we shall be discussing volumes of similar shapes. The diagram shows two mathematically similar vases. Vase A has height 20 and volume 1500 or 1500. Vase B has volume 2592. Calculate H, the height of vase B. So in the previous video, we discussed the similarity of areas, and we said that A1 over A2 equals S1 over S2 to the power of 2. And we said that the reason is that the unit of side is centimeter and the unit of area is centimeter squared. So we have to square the ratio of sides in order to obtain the ratio of areas. Just in exactly the same manner, just a very similar concept to this, we create a new equation in a sense. V1 over V2 equals side 1 or S1 over S2 to the power of 3. And the reason for the power is that the side is in centimeters and the volume is in centimeter cubed. So it's exactly the same idea. It's just that we're raising to the power of 3 to account for the volume instead of the area. Let's try to apply this to this problem. We also mentioned in the previous video that by convention, just to keep things consistent, we're going to use 1 for the bigger shape and 2 for the smaller shape. So let's plug in the values. We are given that the vase A has height 20 and vase A is the smaller one. So 2, the side of 2 would be 20. And the volume of the smaller object, so V2, would be 1500. And then the volume of the bigger object would be 2592. And we want the height of vase B, or the bigger height or the bigger side. So this would be X in a sense. So let's rewrite the equation. 2592 divided by 1500 equals X over 20 to the power of 3. In order to get rid of the power, we're going to take the cubic root on both sides. So the cubic root cancels the power of 3. So we get X over 20 equals cubic root of 2592 divided 1500. And we can use the calculator to evaluate this. Again, you just write cubic root on the calculator and then press on the fraction button. In the numerator, you write 2592. In the denominator, you write 1500. And you get 1.2 for this expression. So the entire thing here is equal to 1.2. And this is equal to X over 20. We can write over 1. And we can cross multiply. So 20 multiplied by 1.2 equals X times 1, which is X. Therefore, X is equal to 20 times 1.2. And that gives us 24. So therefore, X equals 24. This is the final answer for this question. 24 is the correct answer. Two barrels in the diagram are mathematically similar. We have H and 90 for the heights, and we have a capacity of 100 liters and 160 liters. So capacity is another term for volume. Whenever we see the word capacity, this is the same as volume, and liters is another way of measuring the volume of an object. Now, you might consider converting from liters to centimeters cubed, but this won't really be necessary since we're interested in a ratio anyway. So we don't really need to make the conversion here. We can just use the volume as given without any conversion. But just FYI, you should know that 1 meter cubed and 1 centimeter cubed are positioned like this. And 1 liter is exactly in the middle. FYI, for your information, to go from meter cubed to liter, you multiply by 1000. To go from liter to centimeter cubed, you also multiply by 1000. So if we were to convert, we would multiply each of these by 1000, but they would cancel out as soon as we put them in a fraction. So it doesn't really make sense. It would be a waste of time to convert anyway. So let's go back to our normal procedure. V1 over V2 equals S1 over S2 to the power of 3. Now, V1 is the volume of the bigger object, so this would be 160. V2 is the volume of the smaller object, so this would be 100. S1 would be the side of the bigger object, and this is 90. S2 would be the size of the smaller object, which is H or X or whatever. And we rewrite the equation, so 160 over 100 equals 90 over H, all to the power of 3. And we take a cubic root on both sides. And the power 3 cancels the cubic root. So we are left with 90 over H on the right. And we calculate this or evaluate this on the calculator. So just click on Shift and square root to get the cubic root. And then click on the fraction button. Write 160 in the numerator. Write 100 in the denominator. You get a long decimal. So 1.1696. We do over 1 and we cross multiply. And we get 1.1696H equals 90. And then we divide by 1.1696 on both sides to get rid of this number here. Finally, we divide 90 by 1.1696 and we get H equals 76.949 or just 95 or even 77 would work. So actually 77 would not be considered correct here, so don't over approximate. 76.95 would be perfect, or even 76.9, that would be okay. Some cones are mathematically similar. For these cones, the mass m grams is proportional to the cube of the base radius r. One of the cones has mass 1,458 and base radius 4.5. Find an expression for m in terms of r. So in order to find an expression for m in terms of r, first of all, we consider the proportionality expression. So the mass m is proportional, so equals to k, to what? To the cube of the base radius r. So k times r power 3. And our target is to find the value of k. So we use one of the examples or one of the given values in order to find that. So we have m and r here. All you have to do is just 1,458 equals to k multiplied by 4.5 to the power of 3. 4.5 to the power of 3 gives us 91.125. So therefore, 1,458 equals 91.125 multiplied by k. And k equals 1,458 divided by 91.125. So 1,458 divided 91.125. This gives us 16. So k equals 16. And we rewrite the equation finally. M equals, instead of k r power 3, it would be 16 r power 3. Let's check the marking scheme to make sure that I is correct. I is in fact correct. 16 r power 3 is the correct answer. Double I says two of the cones have radii in the ratio of 2 to 3. Write down the ratio of their masses. So this is very simple. You simply realize that the mass is proportional to r power 3. And this is another way of saying what we already said in previous questions, which is V1 over V2 equals R1 or S1 or whatever over R2 power 3. So the ratio of volumes is the cube of the ratio of sides. And we already were told that the mass is proportional to r power 3. So the ratio of masses as well would be equal to the cube of the ratio of sides. So therefore, you don't need to do a lot of calculations or anything. All you have to do is just raise this to the power of 3. So 2 power 3 is 8. 3 power 3 is 27. So your final answer here would just be 8 to 27. And for future reference, instead of volumes, if we get masses, we can use the exact same equation. M1 over M2 equals R1 or S1 over S2 all to the power of 3. So mass and volume have the same equation in a sense of similarity. So 8 to 27 here is the correct answer. The diagram shows two glasses which are mathematically similar. The larger glass has a capacity of 0.5. The smaller glass has a capacity of 0.25. The height of the larger glass is 13. Calculate the height of the smaller glass. So again, we write the equation down. V1 over V2 equals S1 over S2 to the power of 3. Now, V1 is the bigger volume. So the bigger volume here is 0.5. And we said we don't have to convert from liters to centimeter cube because they will cancel out anyway, so it doesn't matter. And V2 has 0.25. The volume is 0.25. The larger side is 13, as given in the drawing. You can see that the height of the larger object is 13. And you want the height of the smaller object, which is x. So we rewrite the equation 0.5 divided 0.25 equals 13 over x to the power of 3. Calculate 0.5, or actually first let's take the cubic root so as not to follow a different procedure. Let's take the cubic root on both sides as we did before. Let's cancel out the cubic root with the power 3. So on the right we get 13 over x, and on the left we evaluate on the calculator cubic root of fraction, and in the numerator we write 0.5, in the denominator we write 0.25, and we get 1.2599. Of course, 1.2599 can be easily approximated into 1.26 because 99 is very evident, so it's just pointless to write it down. 599 can just be 6. So we have 1.26 equals 13 over x. We do over 1 to cross multiply. And we cross multiply like this, and we get 1.26x equals 13. Then we divide by 1.26 on both sides. We cancel these out. And we finally get x equals 13 divided by 1.26, which is 10.3174. So just 317. This is more than enough. Let's check the marking scheme. So 10.317 would be perfect. 10.32 would be okay. 10.3 even would be okay. 3 significant figures, I guess, is optimal. So you can just write 10.3 here as a final answer. So in this question, we're told the diagram shows two jugs that are mathematically similar. Find the value of x. So this is easy. Here, you're just given sides, no volumes, no areas, nothing. So just to get the the x, the missing side, you just write a very simple equation where 7.2 divided by x is equal to 15 divided by 25. So why did I position them in this way? It's sort of like similar triangles, which we had a previous video about. So the corresponding sides are placed over each other. So these guys have to be in the same fraction, and these guys have to be in the same fraction as well. And all you have to do next is just cross multiply. So you get 15x equals 7.2 times 25. So 7.2 times 25 is 180. So 15x equals 180. X equals 180 divided by 15. And that gives us 12. So the answer to the first question is 12. Let's check the marking scheme. 12 is the correct answer for A. For B, we are told the diagram shows two glasses that are mathematically similar, so we can clear the screen. It seems like this is a new problem. The height of the larger glass is 16, the volume is 375, the height of the smaller glass is y, and the volume is 192. So let's write down our equation. V1 over V2 equals S1 over S2 to the power of 3. Now, V1 is the bigger volume, and this is 375. The smaller volume is 192. The bigger side is 16, and the smaller side is y, and we want to find the value of y. So let's rewrite the equation. 375 over 192 equals 16 over y to the power of 3. Take the cubic root on both sides. Cancel out the cubic root with the power 3. And you get 16 over y equals, and you evaluate the left-hand side on the calculator. So you get 375 in the numerator, 192 in the denominator, and you get 1.25 for the entire expression. Finally, you do over 1, and you cross multiply, and you get 1.25 y equals 16. So we divide on both sides by 1.25. We cancel these out, and 16 divided by 1.25 gives us 12.8. So y equals 12.8. This is the final answer. And 12.8 is the correct answer in the marking scheme as well. Two containers are mathematically similar. Their volumes are 54 and 128. The height of the smaller container is 4.5. Find the height of the larger container. Again, quickly now, V1 over V2 equals S1 over S2 power 3. V1 is the larger volume, so this is 128. This is 54. S1 is not known because we want the larger side, but S2 is 4.5. Be careful where you place your numbers. We said that 1 is the larger, just to keep things consistent. So now you have, let's just put X instead of S1 here, make things more familiar. So X over 4.5 to the power of 3 is the same as 128 over 54. And we follow the same procedure again. Cubic root on both sides. The cubic root cancels the power. You get X over 4.5 equals, and then you evaluate the cubic root on the calculator. You have cubic root of a fraction, 128 in the numerator, 54 in the denominator. You get 4 over 3 for this, and you cross multiply. So 4 times 4.5 equals to 3x, and then we divide by 3 on both sides. We multiply 4 times 4.5 on the calculator, you get 18. So this is 18, and then 18 divided by 3. So x equals to 6. This is our final answer. And 6 is the correct answer here. This is another problem of the same nature again. We have V1 over V2 equals S1 over S2 to the power of 3. So V1 here is 0.5, V2 is 0.25. S1, so the height corresponds to the larger volume. So we're going to put 8 in S1 here, and we're going to put X in the other one. And we get 0.5 divided 0.25 equals 8 over X to the power of 3. Cube root on both sides. Cancel the cube root with the power. Evaluate the cube root on the left. So cube root of 0.5 in the numerator and 0.25 in the denominator. You get cubic root of 2, which is 1.2599. So 1.2599 equals 8 over x. And like we said before, 99 makes it easy to approximate. So this is just 1.26. We can write over 1 to cross multiply. And we get 1.26x equals 8. Divide by 1.26 on both sides. You get x equals 8 divided by 1.26. And that's equal to 6.35. Check the marking scheme. 6.35 is the correct answer. Another one of the same style, but here we want the volume, so this might be a bit different. And we also need to convert to milliliters. So this problem is relatively new. Let's write down the formula. V1 over V2 equals S1 over S2 to the power of 3. Now, the big height is 30. The small height, excuse me, I made a mistake, I apologize. The big height is 75, of course. I didn't read carefully. So this is 75, and the smaller height is 30. The large container has a capacity of 5.5, and we want the capacity of the small container, so x. Now rewriting the equation, we get 5.5 over x equals 75 over 30 to the power of 3. Let's just evaluate the right-hand side on the calculator very quickly. So 75 divided by 30. This gives us 2.5, and then we raise the answer to the power of 3. We get 15.625. So 5.5 over x equals 15.625 over 1. Cross multiply. 5.5 equals 15.625x. Divide by 15.625. Cross. So 5.5 divided 15.625 equals 0.352. So x is equal to 0.352 liters. And we want the answer in milliliters, so we multiply by 1,000. So this is liters, and then you move 1, 2, 3, you get 352 milliliters. 352 is the correct answer in the marking scheme. This is our final question in this video. Triangle ABC is mathematically similar to triangle PQR. The area of triangle ABC is 16. Calculate the area of triangle PQR. So in order to calculate the area of triangle PQR, we use the formula for the areas. So we say A1 over A2 equals S1 over S2 to the power of 2, because this is area, not volume, remember. A1 is the bigger area, and that's what we don't know, so we just write X. A2 is the smaller area, ABC, so this is 16. S1 would be the bigger side, so 12. S2 would be the smaller side, so 8. And we get the equation X over 16 equals 12 over 8 to the power of 2. We can evaluate the right-hand side on the calculator. You just divide 12 by 8, you get 1.5, square the answer, you get 2.25. So we can do over 1 and cross multiply. X equals 16 times 2.25. So 16 multiplied by 2.25, that would give us 36. So therefore, the area of the large triangle is 36. Let's check the marking scheme. So AI is 36, which is correct. For double I, we're told the triangles are cross-sections of prisms, which are also mathematically similar. The volume of the smaller prism is 320. Calculate the length of the larger prism. So if you're familiar with the Toblerone chocolate bars, they look something like this. So this is what we call a triangular prism. We have two triangular prisms here that are mathematically similar. One of them, of course, is larger than the other. We already know that the larger one is PRQ and the smaller one is ACB. We want to get the length of the larger prism. So the length here is like the height. So this side here, we're trying to get this side here. And you should know, of course, that the volume of any prism is equal to the base area multiplied by the height. So if we get the volume, we can get the height because we already know the two areas. Excuse me. So we already know from question I that the area of triangle ABC is 16, and we figured out that the area of the other triangle, the bigger triangle, PQR, is 36. So we already know the area. So in order to get the length, we just need to get the volume, and then we can substitute into the equation and get the height or the length. So how do we get the volume here? We use the equation, of course. So V1 over V2 equals S1 over S2 to the power of 3. We want the volume of the larger prism. So V1 is the unknown here. So let's write X. V2 is the smaller volume. So this is 320. And the lengths are 12 and 8. So we have X over 320 equals 12 over 8 to the power of 3. We calculate the right-hand side. So 12 divided by 8 to the power of 3. This gives us 3.375. So X over 320 equals 3.375 over 1. And we can cross multiply to get X. So X equals 320 times 3.375. 320 times 3.375 gives us 1080. So this is the value of X, which is the larger volume. So now that we have the volume of the large prism, we substitute it into the equation. So the equation is volume equals base area multiplied by height. The height is the length, which is what we're looking for here. Let's call it L, for example. The volume is what we just calculated, 1080. And this is equal to the area, which we already have because we have the larger area, which is 36, multiplied by the length. So 36 times L equals 1080. So the length that we're looking for as a final answer would be 1080 divided by 36. So 1080 divided 36, that gives us 30. And 30 is the final answer. So just to briefly summarize what I did here, we were required to find the length of the larger prism. So we are required to find this length here. And we should know that the base area, the area of the triangle, this area here, multiplied by this length gives us the volume. So the volume is the base area multiplied by the length. So in order to get the length, we needed to get the volume and the base area. The base area was already obtained in question A. The base area is 36. So we already know that from question A, or I mean question I. So from question I, we know that this value is 36. The volume is obtained in the similar way that we've solved in the entirety of this video. So all the questions in this video were very similar to each other. We just do the ratio and power 3 and whatever, and we get the volume of the larger prism, which is 1080. So now we have a very simple equation, 1080 equals 36 times L, and you find L by division. So the value is 30. Let's check the marking scheme. 30 is the correct answer, thankfully. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.